Welcome everybody. Today we're going to be looking at 8.1, simplify and multiply rational expressions. So rational expression is a fraction of two polynomial expressions. So today we're going to work on simplifying. So to simplify a rational expression, we are going to factor everything that can be factored, simplify using exponent rules. So just a reminder, if you're multiplying two things with exponents, we're going to add the exponents. And if we're dividing two things with exponents, we are going to subtract the exponents. And then we're going to simplify and divide the binomials as much as we can. With multiplying, the way they recommend it is doing monomials only, multiply them together and then simplify. So that's one way you could do it, or you could cross simplify if you'd rather do that. So that's personally how I like to do it. So cross simplify is an option. And then with binomials and trinomials, we're going to factor everything first. So factoring is going to be a big part of this unit, and then simplify. So in problem 1, we're looking for what could we simplify in that rational expression. So I see a 12 and an 18, so both of those are divisible by 6. So if I divide this by 6, it's 2. Divide this by 6, it's 3. Then with the x's, I could subtract them. So 5 minus 2 is 3. So because the 2 is smaller, it goes away, and this 5 turns into a 3. And then this y has an invisible 1, so it's the smaller one. It gets subtracted, and the 3 turns into a 2. So what we're left with is 2, a y squared is left on the top, and 3, and an x cubed is left on the bottom. So whenever you have monomials, you can multiply them together and then simplify that way, or you could simplify by cross-simplifying first and start dividing them there. So up to you. Last year, a lot of students liked multiplying, so I'm going to show it that way. So I'm going to multiply all the numerators and then multiply all the denominators and write what I get. So 3 times 8 times 2 is 48. And then with the x's, we have an x3 and an x to the 5th power, so those add to be x to the 8th. Then 4 times 15 is 60. This x has a 1, so the 1 and the 4 add up to be a 5. So now we can simplify. I've got to figure out what can go into 48 and 60. So those can both be divided by 12, I believe it is. So this turns into a 4. This turns into a 5. So one nice thing about cross-simplifying versus doing it this way is like 48 and 60, I have a hard time figuring out what goes into that. So what I could have done, actually, well, I'll show you this in the end. So with the x's, the 5 subtracts, and then the 8 turns into a 3. So we are left with 4 x root 3 over 5. So that's the way my students liked it last year. Personally, I don't like that way because I have a hard time figuring out what goes into 48 and 60. So what I do is at the beginning, I start crossing things off. So like 2 goes into 4 twice. So that I can divide those. 2 goes into 8, so you can do this diagonally. So the 2 leaves, and the 8 divided by 2 is 4. 3 and 15 are both divisible by 3, so the 3 leaves. This turns into a 5. So really all I'm left with now is a 4 on the top and a 5 on the bottom. And then with the x's, same idea, we can subtract those. So like x to the 3, I could subtract that, and this x to the 4 turns into a 1. And then I've got an x to the 1 and an x to the 1 and an x to the 5 on the top. So both of the 1's could leave, and this 5 could turn into a 3. So I'm left with an x to the 3 on top. So that's what I mean when I say cross simplify. That was another way to get to the exact same answer. And that makes more sense to me, just because I'm working with smaller numbers. But totally up to you which way you want to do it. When we start pulling in factors, when you have common factors on the top and the bottom or diagonally, you can simplify them. The reason being, if I had something like 3 divided by 3, we know that's 1. So if I have something like x plus 2 over x plus 2, that's something over itself, it also equals 1. So if you have like a full factor over a full factor, it equals 1, which usually we just cross it off because if something turns into a 1, it's invisible. So in problem number 3, the x plus 5 and the x plus 5, they equal 1. So they really just turn invisible. They leave. So I'm just left with a 2 over 3. Number 4, they've already factored it for us. So again, we're going to look for common factors that we could simplify. So 2x minus 1, 2x minus 1 equal 1. X plus 4, x plus 2, those can't simplify because they don't match. 4 and 18, though, those are both divisible by 2. So this divided by 2, this divided by 2. So we're left with a 2x plus 4 on the top and a 9x plus 2 on the bottom. And we are not going to multiply them out. We want them in as factored form as possible because that lets me see what can simplify. On 5, even though that x plus 2 on the top is not in parentheses, it's still a group, so that can cancel out with the x plus 2 on the bottom. Again, remember, they're not just canceling, they're dividing and turning into a 1. So when everything is crossed off the top, you really are left with a 1. So 1 over x minus 5 is what we're left with. So anytime the whole top cancels out, really you're left with a 1 because it's dividing to equal 1. Number 6. So I can't tell you how many students will look at number 6 and say, ooh, 6 divided by 3, that's 2, and cross them off. So you cannot do that because of the plus signs. So what you have to do is you need to factor first. So you can only cross them off if the factors match. Or if they're monomials and like you've multiplied them together, multiplying you can cancel stuff up, but the plus signs you've got to do the factoring. So on the top, I've got a GCF of 2. So if I take out a 2, I'm left with 3x plus 2. The bottom, there is no GCF, so I still have 3x plus 2. But thankfully, they match, so these groups can cancel. So because they're like a full group that matches, they turn into a 1. So 2 times 1 is just 2. So with your simplifying, when there's a plus sign involved, it has to be, or a minus sign, it has to be a full group that can simplify. So make sure you're being careful with that. All right, let's try 3 more problems. So number 7, already factored, super nice. I see an x minus 2 and x minus 2. X plus 3 and x minus 3 are different, so they cannot simplify. And then 4 and 8 can simplify. So I'm left with a single x plus 3 over 2x minus 3. Okay, number 8, I see no parentheses, and I have to factor it in order to cancel things out. So I see 3 terms on the top, so I'm going to try out the x. So I'm looking for 2 terms that multiply to -6 and add to 5. So 6 and -1 would work. So the top turns into x plus 6, x minus 1. The bottom has 2 terms. So I'm first going to look for GCF. So the GCF of this is x cubed. So that turns into an x cubed, x squared minus 36. Ooh, x squared minus 36, that should look familiar. That is difference of squares. So if I take the square roots of those, I can create a new factor. So on the bottom, that x cubed came out, and my 2 factors are the x and a plus 6 and x and a minus 6. We are going to use difference of squares a lot, so it's really important that you guys look for that. So my x plus 6 is simplified, so I'm left with an x minus 1 over x cubed, x minus 6. All right, one more. So this one, we've actually got 2 different groups multiplying, but we've got all these like trinomials. So we are going to try to simplify first before multiplying. So we're going to do some factoring. So -6, 1, I'm trying the first one. So 3 and -2 would work. So I've got an x plus 3, x minus 2. On the bottom of it, and you have a -3 and a 2. So 3 and -1 would work. So x plus 3, x minus 1. Then in the other set, on top there's a GCF, so I can take out that 3. On bottom, ooh, there is a GCF. We could take out that 4. So we could do x squared minus 8, nope, not 8, divided by 4 is 2x minus 3. So now that I've taken out the 4, now the factoring is a lot easier. So looking for that GCF is helpful. So that'll be -3 and +1. You'll notice sometimes I do like little pieces of work off to the side to help me, just because I don't like rewriting it over and over again. All right, we're looking for common factors. So you can simplify up and down, or you can simplify diagonally. This one doesn't have any diagonals, but you are allowed to do that. X plus 1, and nothing else matches. So we're left with 3x minus 2 over x minus 1, x minus 3. So you do not need to multiply that all back out. You're just going to leave it as it is. Ooh, I forgot a GCF. There should have been a 4 in front of this. So there should be a 4 in front of there. So do remember your GCFs. If that 3 and 4 in front could simplify, I should, but because they can't, I just leave them as they are. All right, that is 8.1. Good luck, and I hope it goes well.